Okay, everyone, good afternoon. Thank you for signing on. Today, I just want to do a quick training about Omniprobe needle exchange. If you have any questions, feel free to put them in the chat, please. I will monitor that as I do the training. What we're going to do is look at the Helios user interface. We'll take a quick look at the existing needle and then change a needle and calibrate the position. Really, this is something you should do, I don't want to say every time you run a lift out, but every now and then it's a good practice. The needle cost is around $10, and if you think about the payoff for changing the needle when you have a critical experiment on the line, this is something really we hope all of you guys will be able to do. So I'm going to first turn on the electron beam. A sample is not needed. What we're going to do is just look at the needle itself. Often this is a really good idea before you start your session, just to go ahead and look at the needle, see what kind of shape it's in. Whoops, I'm going to zero the beam shift here, zoom out. Let's speed up our scanning. Okay. And to insert the needle, of course, we go here to the patterning tab. You can see that the Omniprobe selection is grayed out. It's because I haven't linked my Z to working distance. Because you can see in the CCD, I have no sample. I don't really care what the working distance is. I'm going to go ahead and link, and that will allow me to insert the Omniprobe. There it is over at the park position. If you ever insert the Omniprobe and it doesn't, let me turn down the contrast, and it doesn't come over here to this 9 o'clock position and be perfectly horizontal, something's gone wrong and you should change the needle anyway. I'm going to now, with the Omniprobe software, let's overlay that real quick. Take the needle to the eucentric high position. Eucentric high should be directly over the yellow cross, the center of the electron beam image, and it will be 300 micron above your sample surface. So this should be, if everything's calibrated, this should be a nice position to take the needle, and we see clearly this is not in great shape. So it's good that we checked this. Let's go ahead and do this. Let's turn on the ion beam and take a look from that perspective as well. Looks like the last user was doing some low kV cleaning. Let's do 40, that's fine. Lower the mag, and there we see the needle. I'm going to drop in Z and just bring it kind of to the eucentric point so we can zoom up a little bit. Because of the scan direction of the ion column, it does appear that when I lower the needle, it moves up in view, but that has to do with the scanning direction. So somebody has done a lift out and left the needle in pretty rough shape. You know, you actually probably could do a lift out with this, but let's go ahead and change it. So checking the needle before your session can save you the headache of doing your final thinning or doing your initial thinning and being ready to lift out and then realizing you need to vent and change the needle. Okay, electron beam is off. What I'm going to do now is go ahead and vent the electron column. Yeah, let me move this just a little bit. Obviously, we need to vent to atmosphere to remove the Omniprobe needle. So, chamber is now venting. That should take 2 minutes or so. Let's look over here at the Omniprobe, and I'll point a couple things out as we're venting. So this is the Omniprobe body. This piece here is just a cover. It just keeps things from contacting the probe end. It's got 3 pins that align to 3 notches, and we put a cover on it just really for dust, safekeeping, etc. This is a ground connector. So we're going to remove that to pull the rod out. In standard operation, this should be connected. One thing that often happens with the Helios is this cable here becomes disconnected. At this point, the Omniprobe rod is electrically floating. It's not grounded, so you may charge it up and find some drift. This, as the probe body inserts and retracts, every now and then this gets pulled free. So if your Omniprobe behavior seems odd, check this connector here. One thing I am going to do right now is I'm going to put my gloves on. The Omniprobe rod, from basically this point in, is under vacuum. So you just want to make sure you handle it with gloves at all points, just like anything else that you put in the electron microscope. One thing you guys may have noticed is while venting, this section here, there's a little vacuum bellows inside, so as the pressure equilibrates, there's no longer atmospheric pressure pushing this down. So this is the Z-axis. Of course, that's with what we refer to as a port frame of reference. So this will insert the rod directly along the axis of the rod here. There's an X direction and a Y direction. Actually, that's reverse, sorry. That's the X direction, that's the Y direction. When we use the Omniprobe software, there's going to be a stage frame of reference. But if you look at the body of the Omniprobe, everything is registered to the port. So the door is open. We can probably hear the nitrogen there. I'm now going to start removing the rod. We have this, which is a fixture or jig to help you remove and insert the rod without damaging anything. This attaches to the end of the Omniprobe body by the 3 pins, but I have to remove the rod a certain distance before I can insert this. So let's start doing that here. Generally what I do, this knurled nut is what seals vacuum, and this portion, this tip, is the rod itself. So I'm going to hold this static and rotate this to loosen. So we hold this here. And after a number of turns, we can see that this is now free to remove. What I want to do is, as this starts to come out, eventually it will clear the top of the jig. I'm going to push this in and rotate. Now the rod can stay. The reason why I want to use this when removing the rod, you might think, okay, I can just pull the rod out. There are some O-rings and things internal that, you know, honestly, it's just a better idea to remove the rod with the jig. We're going to leave this inside right now. One thing I'll show here. So here is the vacuum seal end. I'm going to push this out a little bit. There's a double O-ring. Both sides of this aluminum collar have a little O-ring. These can, on occasion, get pretty dirty and they become a vacuum leak. The sealing surface here, every now and then, you should probably just make sure there's no debris there. So here is our Omniprobe needle, which you can barely see. Let's see, get it in front of that. There we go. So this is what we're going to remove. And to do that, I'm going to come over here to the probe station. This is just a small jig to hold the Omniprobe rod while we remove the needle. In our facility, we have this small Omniprobe kit, and that's reflecting the light. So we have the Ted Pella needles, which are just Omniprobe brand needles. We have the Allen wrench required and a number of tweezers. So please leave the tweezers in here. And also make sure this is a sort of pretty small Allen wrench that I don't know that we have others. Oh, of course, we've got autofocus set on the camera, so it's a little blurry here. Can we show that? Yeah. So you can see it's a pretty small Allen wrench. inside this, let's see, let's go this way a little bit. You can see there are two needles here. We want to pull them out, but I'm not going to do that until I remove the old needle. Okay, so you'll find on the tip of the Omniprobe rod, here, let's see if autofocus now doesn't want to focus. There we go. There's one socket head screw, and there's one empty tapped hole. There should always only be one screw. If there are ever two screws in the tip of the Omniprobe rod, someone has inserted one in a way they shouldn't have. So I'm going to use the Allen wrench here, loosen that, and I can just pull the old needle out with my fingers. We have a box here of what now appear to be hundreds of tungsten needles. We save them, not really for any purpose, but they just go there. Do be careful. I have speared myself with an Omniprobe needle, and it does not feel good. You know, should be very inert, but if a sample you're removing it from the system, you don't know what has been on the end of it, so be very careful. Honestly, this is one of the hardest parts about changing the needle, is getting it out of this. So there's kind of a double stick tape in here. We need to pull the needle free. Don't pull so hard that you slide the tweezers past the tip. If you make any contact with the tip of the needle, you will ruin the needle. So I usually pull a little bit until I feel it start to go, then I'll re-grab. Let's see if I can show these tweezers. These tweezers are flat tweezers, not pointed tweezers, so they give a little more purchase on the needle. Okay, I'm going to just use my fingers and place the needle inside the rod assembly. You want to push it as far in as it will go this way. It will just naturally bottom out. And then we will tighten the one screw. This just really makes electrical contact. Don't over tighten the screw. It's very easy to destroy that. We do have extras, but ideally you should just, same when you load a sample, you really only need 2 fingers, right? If I use any more than that, I'm using way too much force. And now what I'm doing, you can see I'm grabbing here and I'm kind of rotating the rod. It's a little difficult to see, but I guess you probably can see. The needle tip itself is precessing as I rotate the rod. To make calibration easier, I'm actually going to physically bend the needle to try to get rid of that precession. What I don't want to do is bend it vertically because I may touch the base of this with the needle. So I'm going to push it or pull it in this axis. So I find where the maximum point of precession is here at 6 o'clock, and I'm going to just push and bend the needle. And that's actually pretty good. So you see the needle's kind of not swinging around quite as much as it was. You'll never get this perfect, so don't spend too much time on it. You really just want to get it in the ballpark so calibration is easier. There is one needle left in here. We keep the needles in this box. We should always have backups, but we only put one working box out at a time. So if you plan on changing a needle and it's looking low, just let us know. So at this point, I'm still wearing gloves. I'm going to pick this up and put it back in the microscope. Okay, so back to the probe view. Up at the top of this jig, so it's kind of a track that we want the rod to go. And usually what I do is I put the rod kind of like this, and it's now registered within that track. I'm going to put my finger right here at the top, so that way I can push the rod just like this and perfectly nestle it within that track. Don't just try to lay the rod in the track. You will bend that needle. It takes almost no force at all to destroy this needle. So I'm going to register the rod with this notch, put my finger here, allowing me to pivot up. And now very slowly, I'm going to push the rod down. I feel some tension right about here. There's a set of O-rings. Okay, and now you can see the end of the knurled clamping assembly here is against the end of the jig. I need to now remove the jig. Make sure you have your other hand ready, right? Don't just pull the jig out because gravity will send that rod flying in. So I'm going to now pull this out. See, if I let go, that just slides in. So very slowly, I let that come to its resting position. This isn't really necessary, but it's something that I always do just so there's consistency. These clamping rings have socket head cap screws in them, and I just always go heads up. Sometimes these Omniprobe rods themselves have a little precession or curve, and if you always put these locking nuts in the same position, then that curve will be in the same orientation. And again, I'm holding the end of the rod static, and I'm going to tighten. You can get it pretty tight, but again, I'm only using 2 fingers. Never use a tool here. Don't crank this with a tool, you'll ruin it. Even when this is very tight, you should always be able to freely spin the Omniprobe rod. So we now have, we checked our Omniprobe rod, or Omniprobe needle. We saw that the needle was in terrible shape, so we need to exchange it. We vented the chamber, used the jig to pull the rod out. We've put a new needle in, reinserted. We need to add the grounding strap again, and I'm going to put the dust cover on. At this point, we're ready to pump down vacuum. Actually, so let's come here. Okay. Click pump. And I need to put my hand on the door. Okay, there we go. So while we were waiting, one option, so here are the Ted Pella needles. You guys can always buy your own needles, but we do supply them, so they just get rolled into the operation of the facility. So we should always have them. If for some reason you want to make sure that you have some, you're always more than welcome to buy your own. They come in a package of 10 for about $100, $120. So each needle is about $10 and well worth the effort of exchanging. If you found that the needle was in bad shape while you had your sample inside, just lower Z and drop your sample. One thing that happens when you insert the valve, or when you click the button to insert the Omniprobe, the valve opens and high pressure air pushes the Omniprobe in. It causes the needle to over-insert and retract. If your sample is right at the eucentric position, the needle may over-insert and jam right into your region of interest, which would be right where you had your lift out, and you could easily destroy your sample that you've worked so hard on. We're waiting here for the chamber pressure to become good enough to operate, and I'm going to now go over to the other PC. The Omniprobe software, this AutoProbe software, lives on the EDAX PC. Let me go ahead and exit and log out. It's moving to the park position because I was last at eucentric high, which is a good point. I should have gone to park before I went to eucentric high. This number is an indication of how far from the target coordinates you are. So we were about 1 millimeter away. And now we are at park position, and the software is closed. So this is the EDAX PC, and the software that we want is Autoprobe. If it's closed, just double-click Autoprobe. You will be asked to log in. Because we want to calibrate needle position, click Supervisor. I generally don't give out passwords on our streaming, but this one is really not super secure. Password is super, S-U-P-E-R. Oops, there we go. Oh, I was using the wrong keyboard. Capital S-U-P-E-R. We log in, there's a short initialization, and now we're ready to go. We're still waiting on vacuum on the Helios, so I want to talk over some of these functions. We only have one probe, so active probe will always be probe 1. The tilt angle, just ignore. And we have a couple functions here. We have the coordinate axes. We're selected right now for X and Y mode, so we can move in X and Y. I can click Z, and we are going to move in the Z axis. Here are some various speeds. When I do the coarse movements, I'm going to use 60 micron per second. As I get closer and closer to my lift out area, I'm going to use very small movements. But for calibration purposes, we're going to start at 60 micron. You'll see that's pretty close. These are buttons. I can change from stage to port frame of reference. If you come in and when you click X or Y or Z, something doesn't seem right, someone may have accidentally changed the frame of reference. We want to be in stage frame of reference. I can also change from step or velocity mode to step mode. So now our velocity numbers, which were micron per second, change into just micron steps. So I can go 5 micron in one direction, 10 micron in one direction, etc. For the purposes of calibration, I'm going to stay in velocity mode. Here are some pre-configured positions. We will use park and we will use eccentric high. I can't really think of a situation where you want to drive directly to eccentric. When I say calibrate, what I mean is we're going to drive to the eccentric position though, and we will click edit to tell it, okay, the new needle is right at the eccentric point. Then park and eccentric high are calculated off of that position. So let's check our Helios. Oh look, we're at vacuum, so that's great. Turn the beam on. So again, we have no sample end, so it doesn't matter what my focal value is. I am going to focus on the needle tip though, but right now I can just link, which gives me the capability of inserting the Omniprobe. I'm going to use the ion beam for tracking Z movements, and I'm going to use the electron beam for tracking X and Y movements. So I do need to turn the ion beam on again. So you see, we've inserted to park and we're way off. I guess in microscopy we're way off. This is what, 0.5 millimeter? Yeah, so 500 micron, not a tremendous area, distance for me to have bent the needle. And let's see, we should not be able to see at this point, should not be able to see the needle, which is correct. I'm going to now overlay the Omniprobe software a little bit. And actually I need to, move. There we go. I am going to go ahead and just drive to eccentric high. I have no sample. This is perfectly safe. You see that our distance number shows we were 1 millimeter away at least. And I should be imaging here. This editing of the eccentric position really honestly is the critical part of exchanging the Omniprobe needle. A lot of people don't do it, and you can see how far off I am. It's very easy if I were 500 micron the other way to just destroy your sample or destroy your needle, which wastes your time. So after you change the needle, make sure you always go through this step. Really at this point, my goal is to drive the tip of this needle to the center crosshair in both electron beam and ion beam. I do want to make sure my beam shifts are zeroed, because the assumption is that we have a well-aligned system and the yellow cross represents the true eccentric point. I'm going to drive. You see, can't see any movement at all because I'm at a really low velocity. So let's go to 60 micron per second. I'm in X and Y mode, and that's why I'm using the electron beam. So with the electron beam, I'm going to drive to the yellow cross with X and Y. And now the needle is pretty much right over in Z-axis the yellow cross or eccentric point. So again, because of the raster, the needle will move up when I click the down arrow. So I'm actually moving down towards the sample. Okay. And at this point, we want to zoom up a little bit closer. Okay, there's the needle. 60 micron per second, way too fast at this point. Let's go to 10. Okay, in electron beam mode, I am in the X and Y axis directly over the eccentric point, and I'm a little below eccentric, so I need to come to the Z axis and now raise the needle up. Let's check again with electron beam. Pretty close. So now one thing you'll see, let me go to much smaller movement, 0.2. Oops, that was Z mode. Pay attention. There we go. So it should make that point. In the electron beam view, Z movements move directly in and out of the plane of the computer monitor. So you can push Z and the motors are actually moving, but you don't really see an apparent movement, and it's because the needle is coming directly towards you or away from you. Okay, now let me go back to the ion beam, and we'll need to fix that mistake I just made. As I zoom up, and let me focus. Astigmatism's pretty bad. Fix the astigmatism. Okay, this is actually good enough for what we're doing right now. And I need to go up. So you can see that I am at the yellow cross in the electron beam mode. X and Y is at the yellow cross. In the ion beam, I'm not directly at the yellow cross. That is actually okay. It just means that we have a little bit of issue with our beam coincidence. The electron beam is not looking at the exact same position as the ion beam, and that just happens over time. Most important for the Z height is that the tip of the needle intersects a horizontal line which runs through the eccentric point. So just look there, drop it just a little bit. I'm at some fairly high magnifications too. I'm probably, what I would consider too high. This is close enough. You can spend a ton of time on this. So at this point, I am ready to finalize calibration. I'm going to click eccentric. I'm going to click edit. And it asks you, are you sure you want to edit the eccentric position? Yes, of course. And now what has happened is eccentric high has been recalculated. It's going to be, if I look at the electron beam, 300 micron, I think 300 micron, directly above the surface. So if I click eccentric high and say go to, you notice it almost appears like there's no movement at all in the E-beam mode. All that's happened is the needle is now out of focus. So we can actually use that to measure how far above are we. We were at 4.1. Here we are at 3.8. So 300 micron above the surface. And if we go back to the ion beam, don't see the needle until we zoom out, and there it is, 300 micron above the surface. Now we're done with our session. We need to go to park. Do go to park before you retract the beam, the Omniprobe, because just like it over inserts sometimes when you go to retract it, there's a little hysteresis in it, and you don't want to, at this point, the assumption is we have a TM lamella on the end of it. And now if we zoom out with electron beam mode, the tip of the needle should be exactly where we expect it to be. And it is. Let's do this. Yeah, see, it won't even let me drive to use centric, which is good. I'm going to really quick go to use centric, and I will show you what it looks like when you insert and retract the needle, just so you can see that over insertion and under insertion. Just, I guess, to belabor the point why you need to be careful. Okay, so here we are right at the yellow cross. Let's see if we catch it at this mag. If I pull the Omniprobe out, didn't really see much, but let's see where it goes when I put it back in. Insert Omniprobe. Yes, I do want to. So kind of moved pretty far. Okay. All right, guys. Well, that's it. So what we did is check. So the assumption is that when you come in for your microscopy session, right, the chamber should be under vacuum. It's a really quick check. Just turn the beam on, and you don't even need to insert your sample. Turn the beam on and look at that needle. You will save yourself a lot of time if you can exchange the needle during your regular sample loading. You can, I do say it's very easy to change the needles. They're relatively cheap. This is true. You can get a good 10 plus lift outs out of a needle if you're careful about how you use it. If you always weld onto the edge and not the top of your lamella, you can get more and more lift outs out of it, but don't suffer through a blunt needle and just because you're not entirely sure how to change it. So let's see, we're at park. We need to now make sure we retract the Omniprobe. When venting the Helios, the Omniprobe will always retract. Do keep that in mind if something goes bad and the needle is welded to your lamella. Don't ever, of course we know we don't want to move this stage at that point because you'll break your sample, but also if the needle is welded to your lamella before you've lifted it out, or even while it's still in the pit, if you vent the chamber, it's just going to automatically pull your lamella out. Could destroy it, could cause a problem. So the Omniprobe always automatically retracts when you vent. There's no need to close this software, so you can leave, let me go back over to the EDX PC. You can leave this on. It's a pretty low impact as far as the CPU is considered, so you can leave this open. Usually 99% of the time is open. It's actually, you can't even close it by clicking X. You have to come to log out and click exit. So we'll leave that open there. Hopefully you guys see it's pretty easy. Needle exchange should take you 10 minutes at most. So if you have questions, let us know. Come find myself, Bobby Kearns, Alan Hunter can help you, Haiping. We all regularly do needle exchanges. But this empowers you now if you want to work on the weekends, work in the evening when we're not around. You don't need to worry about a blunt needle. So thanks for signing on. If you guys have any questions, come find us.